Hi, so today we're presenting the Admanox project Cáicu, and it's issue 39. So we've been developing the model, and recently we have changed a lot in the design. And the latest feedback that I received was about the sorry, I'm gonna present my bit, which is the column. But if you have any updates before my presentation, just let me know, because we didn't speak before I start
Uh,
presenting. So
yeah,
do you have bits before mine?
yours is first, I think.
Yeah, so just like last week, this is the pattern we developed, and this is the one that we started working on for the vertical drop. So currently it's a cylinder. This one I did last Monday, which I got feedback that okay, it needs to be at least 2.5 meters wide. This is the latest one, which is I assume is correct. It's 20 meters in height and 2.5 meters wide vertical drop. The first one is one layer, and the second one is 3 different layers where you can actually not see much in gaps, so you cannot see through the holes. This is the latest that I got to in terms of the Cáicu vertical drop development. So because the director is hasn't commented on this yet, or what's the next step, so it's paused in terms of the vertical drop right now. Okay, now
I think so. Carlos told me that he wants to try to 3D print this already to get like an example of how it's gonna look. So
okay.
I assume that could you like they're not attached or anything, right? The 3 layers inside.
Yes.
The right one, I mean. So maybe we can get it ready. I don't know. I don't know. I 3D printed before, and there's a program. I need to give you the name. I can ask Carlos. He's around here. Because you need to pass it through another program, like for the 3D printer, and then you can 3D print. And he wants to do like a small scale like test to see how the printer takes in like the smaller bits.
Yeah, so that's great to know. Yeah, I didn't know about this, but yeah, I think
He just told
it's a
me.
great
Yeah.
test. I think that would be
Yeah.
good. It's a 1 meter. We did at the beginning, it was 1 meter by 1 meter,
Mhm.
and then kind of created the cylinder. But yeah, it would be 1 meter by 1 meter layer stuck together, or I don't know how they would print it. They would
I
print
think
it in
we
pieces.
have the printers here around in the office. I think that he wants to do like a smaller scale, like maybe like the size of a cup,
Okay.
just so that we can so that the printers that we have here can actually print it.
Yeah.
Because
Haven't done
I think
3D
that
printing.
I have the limit dimensions somewhere. I haven't printed in like years, but I have the printer dimensions somewhere, and I can give them to you. 3D
Yeah.
printer, yeah, and then we can get it ready.
Okay.
But yeah, you can continue.
Namibia, do you want me to go back or? Oh,
No, you can go forward.
yeah.
Well, in terms of the platform of design, on this week I'll be working on such the research about how the flooring system is gonna work. I found some interesting information about how actually in a natural context of the ocean, how general fish floats. And I found something interesting about the term swim bladder, that is also called air bladder, and it's actually a buoyancy organ that possesses most of the fish. And this part of the fish in the right graphic It's located like a section of a fish and how it is located. And actually this organ helps the fish to basically to maintain like the floating and naturally makes them like to go up or to sink or to go down based on the gas that is inside this organ. You can continue. So after this information, okay, I have to change that image. But basically in this information could help to the platform system on how the platform will going to works actually, because even though most of the platform or the models were going to be floating, there are a few of them that needs to be like sink or be underwater. So analyzing like how in natural fish works in these swim bladder could help us to identify how to design the mechanisms of the model that will going to go under the surface. So in here is how the structure of a swim of a swim bladder works, and it's actually we decide to mimic like a natural symbiosis between the fish and how it work in our project. And actually this swim bladder has as different functions, but one of the principal are the ability to maintain a gas space inside a fish, and that the gas, the fish itself can vary and change their movement into the waters. The next one. So not only how in a natural context works, how to maintain an object in the surface or sink, but actually is a physics matter. So we've been searching some information about how the buoyancy effects works, and we found about the Archimedes principle, and actually how to understand how the project will works, because we all know that objects in water can have two ways of moves. One, it can be synced, or it can be or it can float, and most of them is because of the gravity and the force that gives each other. So in this graphic illustrates more specifically how this will work, because actually to be able to an object to float itself, it has to be a combination of the forces to maintain like the neutral. But in this case, it's easiest like to think like, okay, we're going to use a floating cube or something. But I think the really challenge will be to create the models that we're going under the water, because we don't want those models go too under, but kind of to design how long will be like under the surface. So this information will be really interesting for all of us to be able to calculate that that density specific, the specific density. The next, please. So on these graphics, actually, it's very interesting. So we decide to put some of the information here on how the Archimedes principle works, and actually, after seeing the image and the information, we can summarize it here, and to know that when we start to designing how we flow the mechanisms of the model, we have to calculate actually how the buoyant force and the gravity that we held each models. So in this graphic, we can see how we can create or manage the model and the materials and also the density we need to create like to make the object to float or to sink based on what we're going to make. So for this part, this one is just the research process. In after this understanding all this information is to look for the different formulas that we're gonna need to estimate actually how much force will the platform of the model will need to be able to sink in a certain level that people can go under, but not that much. And after this research, we actually highlight some important things that Cáicu must needs to satisfy in its design, and is this the solution of how we'll create a neutral buoyancy for the floating ones, and how we we have to determine too the object's weight of each one, because at first before this research, I was thinking like we were thinking about how each model would be like the same in aspect of being kind of the same everything, but after this I can see that each one could be kind of different because of the weight of each one and the function that we have in the next process. And also we have to think, and we highlight this about the density of the materials, so we can check on that later, and to calculate the weight of the people that will be there, so we know the platform won't sink, or if we don't want that, something like that. And next, please. Okay. Those besides the research, we start to sketch a few ideas of the last observation of the model platform. In the first one, and these are the three basic forms that we were creating, and we have actually showed to everyone. But now on the second phase, we're going to transform those sharp vertex to create more smoothness to this form and looks more natural, based on the observation from last interaction of last archive. And some of the tasks to create this already on CAD is to check the radius. But after creating this sketch, we check that it won't be like impossible to create like the connection, because even though the each vertex or each corner will be like in a curve form, we still have this flat sides that could be the space will be connected each one models. Then after this, in the third phase is some elevation axis. So how will in the interior of the models will work? We talk about the structure while we continue on each models, and how this truss will have a cover of it. And about this cover is here in the fourth phase, that we're trying to, that the model has a connection with the vertical drop that Riam is actually working. So here the shell, we have the same pattern that we've been working on the vertical drop, but the inside of the model is what we working first of the cover, because one of the ideas about how we work this model is connected to the information of the research last we are already set, and the idea is that inside the model inside the shell and the structure should be an air chamber, here on this one. And this air chamber will be like different because of the gas inside. It depends. If we want a model to be above the water, the chamber we have is unique wave and gasness of the necessity of the gas to be flowed. But if we want models under the surface, then that air chamber will be different because its properties will be completely different from the other ones. So basically the idea is to have first, it is mute.
Is it me?
No, it is muted, Isa. Isa is wanted to talk. Well, I will continue. Okay, then after the here is an idea of the model that we work, how we work sketchily. First, we have a center that will be the air chamber, then the structure, and then the shell. And the next one, please. And here, these are some zooms of the last images. On the next one, please. And this one is actually what I have explained. This one is not the final sketch. This is a working process, but the idea is to create something basically like this, that we have the air chamber, the structure attached to the air chamber, and the shell. This part of the shell is still in process because in the last observation, we talk about having different shell in because of the function, because here we have people, but under the sea we have different activities basically. So, but in general, we are working on this. Yeah, that's all.
So yes, I like the conceptualization of the boys. I think that from this point, now that you have the sketches, I think that you can start modeling them so that Riam can incorporate it later. So I know that the Riam's modeling in Max, and you're gonna have to model in another platform, software. Sorry. So, do you think that it's gonna be an issue, Riam, if she models it somewhere else and then exports it to you, like FBX or something?
No, I don't think it's gonna be a problem.
No.
What are you gonna use?
Well, I can model this more faster in vectors and then export it to you in 3D maps, because I tried with the last model that I did about a vertical drop, and I did an example to exporting in 3D maps, and everything was okay, so I can do that.
Yeah, that's fine.
Okay, I have a question. Can you go to the plan? Okay, can you go to the earlier stages where you drew?
This one?
I think they will need to start thinking of. Que tu AirPods. De verdad. Me oigo ahora. Okay, we need to start thinking about the connection. So this sketches and the way that it works is very important. Pero let's go to the design of the entire platform. You know what I mean?
O sea, the part where you have go to the plan where you drew, the plan that you drew before.
From last week.
That's up to you. See.
From last week.
You remember how I had some comments on that plan? So I think the same thing would go for these. So now you can imagine this is Riam cylinder, right? So you're gonna take the platform and do this, and make it bigger at some point for the drop off, like this entirety of the design. Like now that you have a better concept, just do the pieces and design it so that Riam can get it into the Max, and then we can join both of them. So try to do the the pattern. I know that you sketched it, but try to do it as
Mhm.
similar as possible to what Riam modeled, so that
Okay.
it can be obvious that it is the same skin.
Okay.
Also, remember like what I said, like let's say if you have three, whatever, maybe like don't make them all of them with skin. Just take a couple, like maybe,
A
you know
few.
what I mean? A few,
Okay.
and add the different texture, because they don't all of them, they don't have to be. It's just, I like the idea that we can get also like other living creatures into the little voids and everything, like small crabs, fish, whatever. But I also like that you have some solid areas for just
Mhm.
like main circulation and drop off and everything. So it's a mix of both that we're doing.
Okay.
And I think that's the next step. And Riam, I'm asking Carlos in the group chat what the dimensions are going to be in the printer, so that we can set up the model to 3D print.
Yeah, it's just I've never done 3D printing before, so I don't know how to. What am I supposed to do? Like what to set up?
So what I did, I don't remember very well because I did it so long ago and I've only done it once. But it was, I remember. So we have like the printer has like a print area, right? It has like this tray, and there's a size limit. So what we usually do is that we scale it down to the size limit. So that's why I'm asking, because he wants to
Ah.
print it in the new printer that we're going to be receiving soon,
Yeah.
and not in the ones here. So I'm asking him what the tray size is, so that you can scale it down to that size, and then he needs to give us it depends on the printer. He will give us a software that it needs to go through, and from there it.
Hello?
Hello, me oigo. Sorry, my AirPods are very shitty. I think that the scaling factor is the most important part. So that's why I'm asking him, and I don't think that should take you long. You should just copy it, or maybe save as a new file and then do the print version.
Yeah, I think it's like a 2D thing. Like I used to like the laser cutting. I don't know if it's kind of similar process, but the laser
Yeah.
cutting is a 2D drawing, and then they just print it. But I don't know, they do it in some specific way, like the layers or something.
I think it's very, I don't know how you used to do the laser cutting, but for us to do laser cutting in college, I remember you needed to like take, let's say, the building apart and do like wall, you know. I don't
Yeah.
know if that's how you used to do it. I used to do it like that, and then it was like, I don't remember very well. And then this is different. This is just like the literal model is gonna go, let's say, imagine there's a software and it's, you just open it and then print from there. But you have to upload it when it's scaled and everything already.
Yeah.
So that's why I'm asking for the scale. Hopefully he'll give it to us soon. But afterwards, I think that the next thing to do is that after Namibia gives you the model, is just creating this like unified structure with the deck and the drop, and that way we can have like a couple of nice images.
Yeah.
Yeah, but I mean, Namibia, if you can work on this in the afternoon when you're done con lo de Hostos, work on this on the afternoon to see if you can do get something done for Riam to work on tomorrow.
Okay.
Thank you.
Okay, thanks.